This device, no. This is the Bluetooth device. Okay. So this is the device we want to communicate. Okay. One device to another device. Even by using Arduino or our embedded microcontroller, or we have Arduino Nano. We have Arduino and Mini, Micro, Nano. You know. Okay. We have lots of things. Okay. So this two Bluetooth device from this using this we're going to send the data to one new Bluetooth device, another Bluetooth device. Okay, in our system. Okay, by using our laptop. Okay, so while using, but we are going to use by using the Proteus. Okay, so, so what you have to do, we want to make the connection. No, so so Bluetooth will be in one port, another Bluetooth will be another port. Okay. So what you have to do, we want to make the port to interconnect. For that we have a software, okay, that is called virtual simulator serial port emulator, okay. So first I'll take that Bluetooth, okay. So this is on that day those who have sent. So even uh, from the library, I selected this HC05 Bluetooth, okay. So those who are install the Proteus, it won't be in the library, okay. Maybe new version it can be available, I think so. Okay. These development kits, Arduino, Nano, Mini, UNO, and some of the sensors and all, we have to download from this library. Can you see here? This library. www.theengineeringprojects.com. Okay. From here to your library. Or else no problem. So I'll tell you how to download that. Okay. Go to Google. Yeah, just type Bluetooth library for Proteus. Okay, that's all. Okay. So click automatically that in the engineering projects link will become, okay. Can go directly here. First you have to download this Bluetooth, okay. Then only you can pick from your library. Otherwise, it won't be available. Okay. So go to this, and here you can see. Can you see Bluetooth library from Proteus? If you just click this, okay. Inside you have to paste this two file, okay. Bluetooth TEP.idx and Bluetooth TEP.lib. Okay, these two file you have to want to put in your Proteus library. Okay, first download this. Okay, that's all. Directly it will be saved in the zip file. Okay, just click here and go to the downloads. Okay, so this just now I downloaded this Bluetooth library for the Proteus. Open the zip. Okay, extract this folder as it is. So now it is opened. Open open the folder. Now can you see Bluetooth tep.idx and Bluetooth.tep. These are the one is simulation file and IDX file. Okay, you have to copy this. Select both the file, copy, and you have to paste in the your Proteus library. Okay, so already told you. In my system, my Proteus is different now. Because my Proteus, I think no need to install. So I have kept my Proteus in this E drive. Okay, just open my Proteus folder. Inside I have library. Okay, just open it and paste it here. Just Control V. That's all. Okay, and if you want to replace it, so I placed here. Okay, how I think everyone install Proteus file no Proteus library. I think everyone has installed the Proteus library. I think. Or what you want to do means go to C drive. Okay, go to C drive. Go to the program files. Maybe program files into 86. I think. Go to there. You can see Lab Center Electronics because I have not installed in direct now. I didn't install my Proteus in the C drive, so it won't be available. And for your system, your laptop will be available. You can see, okay, Proteus and Lab Center Electronics. If you go into the Lab Center Electronics, there will be a library, a folder. You can paste. That's all, okay. That's all. If you do this is the first step you have to do. This is mandatory. After downloading, you want to copy the two file and paste into the Proteus library, and then only you can get this from the library. Okay. So after that, what you have to do next? We'll do the wiring connection. Okay. And again, go to this virtual terminal. Okay. Go to this instruments. Okay. Go to this instrument. Here I can see oscilloscope, counter timer. Okay. I2C, SPI. So everything we have. Okay. Now we need only this virtual terminal. Okay. Just paste this virtual terminal. This is a port. Okay. Virtual terminal is a port. So connect just to transmitter receiver and receiver to transmitter. Okay. And same thing connect here also. Now what you want to do? Just double click this first Bluetooth device, and so mostly the baud rate will be always 9600. Okay. So transmitting baud rate it should be 9600. Change it to comp 1. Okay. So this is a comp 1 port. Double click the second Bluetooth. Now it is comp 2 only. Okay. So comp 2. That's all. You want to make this comp 1, comp 2. So we have completed. That's all we have completed. Okay. Next, what you will do? Uh, to make this two Bluetooth to interface. Okay, we have to download one software. That's so we component and computer want to interface. Okay, it has to communicate now. So for that we need one software that is called this. This small software only. Virtual serial port emulator. Okay, so this link only I send where to download because we have many. We have serial port emulator pairing software. We have many software in the Google. Okay, some will be not work. Okay, some will be very complicated. This is very easy. Okay, just open it. We can pair it and we can do the simulation. This simple one. Okay, that's why this software you can download from here. Just type s- serial port emulator free download for Windows 10. Okay, just click here. I think this one. I think second option. This is not. Now this one. Okay, this is the software. Okay, photo download. So that's all. It is we downloaded. Okay. You want the software? I'll send this. In them. That is very small software only. Even we can. Don't embrace that. Now what we'll do? We'll pair it. Army. Hello.
Yeah, sir. Can we connect like display through via Bluetooth and keypad? Can you connect like that?
Which one?
Like suppose I want to connect the keypad to Bluetooth, and through Bluetooth I can uh, mm, transfer the data via to display.
Yeah, like that we can connect. Okay. From the keypad to Bluetooth.
Yes, yes.
Yeah, from the. So when you press the button, Bluetooth will active. From that we can, the display we can connect it. Okay.
Yeah, yeah. So can you show us that one?
That I'll have to take that circuit. Okay. I'll show you.
Okay.
Now we can pair it. Okay. So open the software. Go to device create. May just select pair, okay, pair and go to next. So already it is comp2, okay, no problem. So while we're doing the real time, you have to compare it, okay, then only in both the Bluetooth you can communicate and do just click finish it. So it is paired, okay. Now you can check it, it be here, okay. It is paired. Now just run the protease. Uh, this is the virtual terminal we can. So we want to just right click and click the echo type character. So what you're typing, it will be here also, okay. So can you see, so I am typing in the first virtual terminal that the same data is connected here. Okay. So like that we can do it. Okay. So this is in for both hard thing. This software is very important. Okay. Only in the port we can connect, we can make it connection. So another thing. While doing if you close this window terminals instead of making off, you have to stop this stop button. Okay. For example, if you close this one and after you close means again you stop, again if you run the Windows terminal it won't open, okay. Then you have to again you have to delete this virtual terminal and you have to place it new one, okay. And 1 minute wait, 1 minute. Now you can see now this is the ports, okay. When you zoom it we can see. So what connector will call us this? What is the name of the connector? This anyone tell me? You've seen the system. So what we call as
UART,
we
HDMI, UART like that.
yeah, this but this we have a name for this connector now. This is one connector.
RS232 like that.
That's a cable.
Okay.
This
HDMI
is
is VGA.
this is a connector. No, we have a name. This is a DB9 connector. Okay, this is we'll call as a DB9 connector. DB9 connector. Okay, this one. These are male and female. Okay, This entire cable will be called as a dependent connector. And you will go for this reset 7 segment. Okay, reset pin. Okay, so those who some not attended that first class know that segment. This is a little bit different. Okay, so using the reset pin, we timer reset, we can stop counting. Okay, this is one example we'll see and go for timer. So making one second first, we'll see the hardware section. Okay. This is the hardware section. Okay. So last class we didn't use the crystal oscillator, but this time we are using 33 picofarad crystal oscillator. Okay. Why you are using means here we need 0 to reset this 7 segment. Okay. Last class just we run this 7 segment. Just it is just displaying the numbers. Okay. But this time we want to reset further. Previously I told no. So crystal oscillator is the heart of the microcontroller. So if there is no crystal oscillator, so in programming we can't do any set reset. So by delays timers that we can't do. Okay. So the oscillator is giving me zeros and ones. Okay. Now first we'll go see the program. Okay. How many of you not came for the 7 segment class?
I didn't came, sir. Just
Your name?
Augustine, sir.
Yeah, Augustine. Anybody else? Who else didn't came? 1 minute.
But this also works on same concept only, no, sir. There we already see previous.
1 minute. Hello, tell me.
This is also looks like the same concept which we already seen before, no, sir. Sound
Yes,
segment like that same.
same only. We are just using only a reset button. That's all. First class
Okay,
you
sir.
came, no, first class. That seven
Yes,
segment. Same
it's a
only. No.
normal without that automatically works because
Yeah, yeah,
depends on code.
yeah. Just we if common honor means we have to go for that X code. Common for display number 1, 2, 3 means we have to give the X code for the 7 segment. Okay. What number we want to display, that for X code you have to go for common anode. For common cathode, for that data you came on that classes and all. How
Yes, sir.
to the same only. Okay. Just giving a push button. That's all. Okay. Just we'll see it. It'll 1 or 2 minutes will take. Okay. Because I'm using oscillator for making the push button to stop. And I don't want to draw again. Okay. Already I have created. I'll just show you. Okay. Directly will go to the code explanation. So this is the order we are from the D port we are connected to the this 7 segment. Okay. And this first pin is MCLR. Okay. MCLR. This is a reset pin. Okay. Now what you will do? This function will call it as a De Morgan theorem. Everyone know the De Morgan theorem. Have you heard? You studied about the De Morgan theorem? No. This is a master. This is a master clear and a voltage programming voltage pin. Okay.
Sir, what theorem you told?
This is a master pin. Okay. This pin, no, this first pin.
You said something, some theorem, you know?
De Morgan's theorem. Have you studied De Morgan's theorem?
Yes, I know. The De Morgan's law, like the every year that PNP transistor, that in between the gap, it will be reduced by off in every year. So
Yeah.
the size of this gap, maybe the Intel company or some company will maintain. So they will reduce in the every year actually.
Yeah, that and also they will be doing the
Yeah, but actually, yeah, I was studied.
optimization.
Yeah, I was studied when I was studied. My professor was asked the one question that like because point 0.5 nano, yeah, this semiconductor we were using silicon, so till we can minimize point 0.5 this gap. But after that point 0.5 or 1 nm
Yeah,
nanometer, it won't able to conduct. Then what will be the De Morgan law? It won't be applied, right? That after that.
yeah,
So what will be the next there? He was asked with me. Yeah, that question. So I got remember now.
yeah. Demands gets used to for the optimization. Okay, when you do while doing the chip designing, expressions no, the expression no, to
Uh,
reduce the expression. If you reduce expression, then the gates will be reducing. Okay, if you reduce this gate, uh, because the ICs our ICs are now working in the nanoseconds, no, picosecond. Okay, I think now it's reduced very speed. Okay, yeah, DMR say nothing but see this MC or if there is bar means whatever you give, it'll make zero. Okay, if bar means zero, no, correct.
Yes, sir.
Yeah, see, this is 1 minute. This is AB bar. Okay, in D bar, you know how they will express it. It'll break A bar plus B bar. It'll come like this. It'll break like that. If a single is if A bar means if you go 1 means what will come? A will be zero. Okay, bar make it as a zero. Okay, same thing in this pin. Here it is bar no. If you press means what happened? This pin will make it at a reset. Okay, so whatever we are doing, it'll make it reset. Okay, that's the thing. For that, for understanding purpose, I showed here. Another thing. So what is the CS? Can you see CS? Those who didn't heard about requirements, no problem. I'll tell. Anyone? What is this CS? Can you tell me? CS. Because in SPA we'll be using. Okay, CS. CS means chip select. Okay, in the microcontroller chip select. Have you anyone heard about that? What is the use of chip select? Because before going I to see, we will we see that. Okay, so I to see space is a very big topic. Anyhow, what is the use of CS means chip select? Okay, the chip select. For example, this microcontroller is master. Okay, from the master we multiple ICs will be there. That is slave. Okay, so master going to send data to the slave. So by using the chip select, uh, we can by using the chip select, we can send from the master which slave the data want to go. That is use of chip select. Okay, you understood, everyone? That's the thing. For that purpose, I taught you that multiplexer and demultiplexer. I think first or second class, no. I think everyone remember mux and demux, correct? Everyone remember, no, mux and demux.
Yes, yes,
Yeah.
yes, yes, yes.
Oh, we see. So what is this chip select means?
That is
I'll show it in the IC itself. Okay. Yeah. So this is the master. Okay. And, in the master, we have two slaves. Okay. So SS1, SS2, and SS3. If you go 0, 0 means this will come. 0, 1 means that pin. The second slave will be selecting. 1, 0 means the last IC will be selecting. Okay. So this is the concept for this chip select. Okay. Again, any same concept only. Okay. In this coding. So one second, I'll show this. We have declared the pick and HTC. Okay. And configuration we are disabled. We no need this. Okay. Here the common. This is the common cathode. Okay. Common cathode segment we are used. Display the 0 to 9. So concept of unsigned character binary pattern. Okay. This binary pattern we are going to go. Okay. So this was 0, 1, 2. Just check me. This is for, yeah, this is for common cathode. No. Um, I think these things, you know how to do the export. Okay, till the line. Anyone want to explain how to do this export? Everyone know, no, how to do for common cathode export and common anode export. I think everyone know. I think, correct?
Yes.
Right. Yeah. Okay. So again, what you know, we are giving void main. Okay. So we are using tris T port. Okay. Set the port as output. Okay. Here we use this D port. Okay. So making this D port as a output. Okay. And here initially we port D. We making clear the port D. Okay. Here by here this infinitive loop option for I equal for integer I and I equal to 0, I less than 10. I will give the I increment. Okay. So here now for port D we are using by binary pattern as I. Okay. To give the delay. But there's delay for 1 second. Okay. In this reset button, we have like, additionally we have given that's all. Okay. So wait, we'll open the hardware. Okay. So this is drawn. Just now I run it. Okay. See, some number is not properly coming now. 9 is not coming properly. 1 is correct. 2 is correct. 3 is not properly coming now. So you want to change in the coding. Okay. So you just tell me the X code, what to change. Okay. So 0, even the 8 is not properly coming. 0 is coming properly and 1 Two is coming. Okay, three is not coming. Okay. Okay, this is a common cathode node. I think you want to change it. And you tell me anyone what to correct export. Just write on a paper and tell me anyone. Now, 1 minute. Hello, can you hear me?
Yes, sir.
Okay, okay.
Yes, sir.
We correct this. Okay.
So this is common cathode display, right?
Yes, yes.
So the
Common
code is
cathode.
correct, no?
Code you have to change.
Yes,
I
sir.
think it is common anode. I think someone changed. Okay. So what you have to do? We'll for three we'll check it. Okay. 1 minute. I'll This is the A segment. A. This is H. No. So 3. So 3 means this. F and G should not glow. Okay. Remaining everything want to be glow. So this of as this is a common cathode. So A, B, except E and F, everything you have to give 1. Okay. For A, you have to give 1. B 1, even C 1, D 1. E you have to give 0. E 0 and F 0. And this will be 1. Okay. So 8 plus 8. This is 12. No. So X. So 12. No, A. A is 10. B is 12. Okay. B is 11. C is 12. So C. CF, I think. Okay. Here in the code, we have to change CF. Then 3 will be grouped properly. And we'll change to C. CF. Okay. So 1. 3 is properly coming. Okay. I think even 4 is not coming. So even tell me what we have to change for 4. 4 we'll see here. Okay. So 4. This is a 4. No. So we'll for 4. F want to be 1 and B want to be 1. G want to be 1 and C want to be 1. Okay. F. So it has coming like this. F. So remaining it should not be below. Okay. 0, 0. This always 1 only. Okay. E is 0. 8, 13. 13 is D. Okay. So 0x D D6.
So 14, no? 8 plus 4 plus 2.
Yeah, 14. 8. Correct. E has to come E6. So E6. Change it to E. Yeah, 4 is coming. Even 5 is not coming.
Sir?
Hello. What will
Yeah,
come for
sir.
P?
Sir, you can I have observed one thing. When H is 0,
Yeah.
that time G is not glowing.
Which one?
When H is 0,
Yeah.
H, so G is not glowing. G is
Uh,
segment
uh,
G.
always H should be 1. Okay.
Yeah.
Because
So in 7, suppose 7 is there, no? So the code for 7 is uh, 8 7.
yeah, 8 7.
But
It will take.
7 is coming fine. But because G is not there in number 7.
Yeah. So 8 is not glowing. No, 8. Now
Hmm.
we'll see 8. Okay, we'll
No,
check the 8.
no. So what I mean is, where is any number where G is there, no
Yeah.
middle segment,
Yeah. Yeah.
that is not glowing because we have given H as 0.
Yeah. Okay.
So is there any relation between H and G, like segment Q?
No. 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 G is separates separate segment. Okay. H is
Mhm.
a separate bit because microcontroller is 8-bit. No.
Mhm.
So 8 bit we have to go always one. That's why.
No, but when we give H as 0,
Yeah.
in this code we have given H for 0, for all H is 0 in this code.
Yeah.
So because of that, G is not working wherever G is required, it is not glowing.
Because near to pin, I think that's why.
Even for number 1 also.
Yeah. It's not glowing
Yeah.
H.
So you see, yeah, H is 0. It's in code for 1. 06 we have given.
Yeah.
That
I will check it.
means we have given H. Yeah.
This pin, you're telling no. Don't say wait,
No, sir, see, one is there, no, 06 for one.
yeah,
We have given, yeah. So in that case, we have given zero for all, for H also. But
yeah,
one is coming fine because G is not required. But wherever G is required, that time we have to, we are giving H as one. If we
yeah.
give H zero for
No,
remaining all G is
always, my thing, no. So don't consider me. Always H has to be one. Okay, we have to follow this only
okay.
because A B C D F G H we don't consider. Okay, H always want to be one. That's all. Okay,
Okay.
only seven thing we have to consider. Whether it's anode cathode. Don't consider about H. Okay, because even in the this external pin, no, because
This is the common cathode, no, sir.
this is common cathode.
Then H must be zero, right?
Whatever common cathode or common neuro, this H, this external pin, no, we have to do always one. Okay.
No, this H is denote a dot, right?
Yeah, this is the dot.
Yeah, dot will glow if we give one for the cathode. If
Yeah.
not, if we give zero, then it won't glow.
For cathode, one will glow. Zero means it won't glow. For
Yes,
cathode.
sir. So why we need to give one? We can give zero, right? For H.
It's no problem. Even though it's zero also no problem. Here, this A to G, no. Here common cathode, which seven segment want to glow, we have to give one. Okay. Because the export will be take for this only. Can you anyway will see keeping this zero will check okay for 5. We'll clear it okay.
Okay.
That's your concept. What I'll do now, some whatever common I'll give one okay. So we'll check it. Because in harder we'll see how many pin. This middle one will be common. Okay. So this is the common cathode. So in the microcontroller, we will be connecting this all 7 pin. Okay. In real time. So common cathode. This cathode commonly will be connected to all the pins G, F, A, B, and E, D. So they'll be all be connected in the ground. Okay. So the pin, and you see the anode is connected outside. And then for a common anode, cathode is connected in the dot. Okay, outside. Now understood? No. Anyway, we'll check both anode and cathode. Okay. Even in the protease, I'll delete this cathode and we can connect for an common anode and we'll check it. Okay. So we'll just make for 5, we'll make it correct.
So,
Now tell.
uh, yeah, earlier it was not correct, right? So that code was for a common anode or common cathode only?
This code for a common anode, I think. But
No, sir, because if it
this
is
this
common
one,
anode means why one is working fine, seven is working fine, only G is not glowing.
this is this code. No, this is I think wrong. We have to make the code as common cathode.
Because same code for common cathode earlier last like previous classes it was working.
Yeah.
Now we are only H because H is one, H is zero in this code, so that's why G is not glowing. So that why 3 was not working, 5 was not working, 9 was not working. Wherever G is not required, that number is working fine.
This code is common anode code. Okay. This is entirely common anode. I am making the common cathode. Okay. Because the hardware, no. The hardware, this is common cathode. Okay. See, wait, if I change this to common anode means everything will work. Okay.
Okay.
Uh, See, here it is common cathode, no.
Sir,
Right?
sorry for the input. I have one doubt. The number of pins are connected to the display, 7 segment display. Like,
Yeah.
can you show it? Like one more, can you show the Proteus?
Yeah. Yeah.
Only 6 pins are we were connected. Seven, huh?
Yeah. But in Proteus, they
But
design
eighth
only.
pin is missing.
Yeah.
It
In
must be
hardware,
eighth pin, right?
no, no. In hardware, it will be 8. In Proteus, the H, no, it will no need connect. For common, the middle pin no common because 7 segment we need to give the coding only for this 7 segment. Okay. For 8
Okay,
Sir,
pin no
since
need.
the
then
last pin is there, last pin
sir,
is
yeah. That
completely
D7 should be connected as a D6. Then it will
Yeah.
work,
Yeah.
I guess.
Yes. Yes. In hardware, no, it will be there, but in Proteus,
Yeah.
it
I got
won't
it.
be.
This is without the dot we are
Yeah, without that we are doing. That's why.
using. So I think here the mismatch I could see the 29th pin. I mean 29th we need to connect
Yeah.
that time. Insert circuit. Yeah.
Yeah. On 29 pin we not connected no for dot. So Proteus will automatically take. Okay.
No sir, RD6 we need to connect, right? Then only that seventh bit will let down. 0 to 6, right? Totally 7.
Mm,
So this 30th we need to connect it to 29.
Yeah. Yeah. I'll change it. Okay.
Yeah. Just check it.
Yeah.
Okay. 29 we are missing here.
Yeah. Missing. Wait.
Yeah, we need to connect to 20.
Now it will come correct. No. Now check.
Yeah, how it is work.
Yeah, okay. Because of the one pin missed, no, that's mismatching. So now, okay. So this is the master master clear, no. So when you press, the signal will won't come. When you if you open, then again there will be start. Okay. Mostly in industries, no. So embedded automations, no. Why you are using push buttons, not using toggle button? In reason. Mostly, I think in industries, machine, high tool machines and all. Okay, even if for the lift, we are using push button. Machineries and all, no. So automation machineries, everything there will be a push button. There will be no toggle button. So anyone tell me what is the reason using push button instead of toggle button? We all using push button. What is the reason? Can you tell me? Anyone? No idea. Can I tell? Okay. So uh, 1 minute. Mostly industries, we'll be using this push button. Okay, we won't use. So this is a push button. Okay, so normal toggle button. Toggle button is switch. Okay, normal switch. So this is a toggle switch. Okay. So see, while using this toggle switch, no, when you on this toggle switch, whatever machines are load or whatever maybe, okay, it will be on. Okay. So if the power supply, okay, if power supply is went, okay, if there's no power supply, if power cut means what happened means even the machine or load will be shut down. Okay, if you're not manually or not not switch off this toggle switch means what happen? If current comes means power comes in, what happen? The machine will be get down. Machine will be running. No. So there is a problem in this toggle switch. Okay, even in your home, fan and light and all using this normal toggle switch. No, when the power cuts means if you not switch off the toggle switch means what happen? It will be remain same. When power comes means what happen? Immediately the switch and fan, if you not turn off means it'll run. Okay, but in the but same thing you are using in the lift or any missions. Okay, in industry, no. So when machine is operating, if you are using in the machines, you are using this toggle switches. So suddenly any problem in the machine or power cuts means what happen? If you're not turning off the switch means what happen? immediately the power comes. What happen? If you any engineers, if you we are doing the repair means what happen? Suddenly the machine will run, so accidents will happen. Okay, but in the push button, say when in the push button switch no, if you press the push button, the supply will come. When you release your hand, the push button will comes in this previous position. Okay, so what happen? Even when the power comes also, the machine will run. When you press the button only, it'll run. Okay, so that's why in the industry, machines and all will they will be having stop button and stop button. Okay, even if when you press the on button or start button, the machine will stop. And if you want to stop the button, we will have separate stop button. If you press the stop button, it will stop. Okay, so that's the reason in the industry they are using this push button for all the machines. Okay, so this is the reason to avoid the accident. So this is the reason you will be using. So even the lift has some problems. So anyone go, will switch off the power and we'll be making the troubleshooting the error. Okay, when the lift suddenly power comes means what happened? The lift won't be operate. Okay, when you make the push button press only, it will activate. Okay, so that's the reason to avoid the accident. We are using the push buttons. Next will timer will timer and pulse width modulation. It will take more time. Okay, so we'll have a class on Monday. Friday tomorrow I'm leave. Okay, so we'll have a class on Monday. So just tell me your attendance. So anyone how to how to create header file and main C files in the coding? I think you know. I think timer
Yes, sir.
will be
Zero.
no.
Yeah, yeah.
Maybe I'm asking others. So we will
Yes,
be
sir.
making the call from that file to a main file. Okay. So meanwhile, everyone just study the registers. Okay, registers will be a little bit tough only. Tough and will if you understand, it will
Sir,
be
can
very
you
easy. Okay.
point out Can you point out the registers? What are the
Yeah,
registers for
yeah.
the
You yesterday asked no.
my
I'll send you.
yeah, in WhatsApp you just send the
Yeah,
details.
I'll
We'll go.
you asking about the ADC register, DAC, timer one, timer two, timer
About
zero,
all. About
pulse
all.
width modulation.
Yes,
Yeah,
sir.
CCP
Yeah.
capture. Okay, all what are the registers in pick 16, 8, pick 16. What are the register? Everything you want. Okay, I'll send you.
Okay.
Tell your attendance.
Muhammad.
Umar, next, Aravind, no.
Sir, Bhagasuri.
Yeah, Arvind Kumar.
Anyone else?
Sir, Guruvel.
That's all. Okay, if you don't miss me, just message me on WhatsApp. Okay. Okay. Monday we'll have the class. Okay. Monday we'll see the timers and pulse width modulation. Just you just go to the register. I'll to send the what are the registers to you. Okay. Hereafter we'll be working only in the registers. Till now we're just coding. Remaining things under SPI CAN protocol, I2C, everything will be working in the registers. Okay. Okay. Thank you.
Thank you, sir. Bye.
Okay. We'll meet on Monday.
Thank you, sir.
Hmm.